4. Okay, so go ahead and write that down. Our y-intercept is 0, 4. When you look at this graph, does it seem to be going up from left to right or down from left to right? Up, right? We read from left to right. It's going up from left to right. So that is called increasing. That's called increasing. Okay, it's increasing. It's going up from left to right. Okay, now we're going to look at the table. So here's how you do that on Desmos. If you're not familiar yet, okay, you're going to go down to Desmos. You're going to, once you have this should stay highlighted, press the wheel and then press the table, and it should automatically add a table for that function.
Table? Wait,
okay, take a look at your x values. Are the x values going up or down? Up, right? Because they get more positive. What's happening here? Those are going up as well. That's why we have an increasing graph. Yes? Okay. You have to be it has to be highlighted. The box for the equation that has to be highlighted. So I said add table Desmos. What do you notice about the y values? Okay, they are going up. So it's increasing. Get it? Okay, we get time to get it to work? Yeah. Okay, so that's that. Now we're going to look at the next one, which is 2, what is it? 2 times 1/2 to the x. Okay, I'm just going to clear everything out. Y equals 2 times 1/2 y equals to the x.
Should I just put 0.5? Can I do that, or do I have to?
You can put 0.5 in there.
1 divided by 2. Just do that.
You can put 0.5 in there instead of 1/2.
Sorry, is that too much work?
Okay, what are you getting a y-intercept of 2?
Oh, wait. I forgot my F. Yes.
You should be getting a y-intercept of 2. Yes?
Yes.
Okay, we're going to roughly go ahead and sketch that now. Okay, roughly go ahead and sketch that on your notes. Oh, I forget what it looks like.
That's not good. Are you bleeding? Are you in a median mode?
Okay, so our y-intercept is 2, 0, 2. Is our function increasing or decreasing from left to right? Decreasing. It's going down. Okay, now you're going to do the same thing with the table, okay? Add a table. If you need to see it again, I'll do it up here. Okay, so it's of utmost importance that that box stays highlighted. Look at this. If I was to click down here, it won't work, okay? If I click this box and then I click the wheel, then I can add a table, okay? It has to be highlighted. Make sure it's highlighted. What do you notice about the y values? They're decreasing. They're getting smaller, right? That is a decreasing graph. So as your x gets bigger, your y is getting smaller. You tracking with me? That's beautiful. Okay. So that's just kind of like looking at visually and kind of picking out what's going on with an exponential. This is the natural shape of an exponential graph. Okay? It has a little bit of a curve in it. Okay? Questions for me on that? Okay. So I want you to look at the equations versus the graphs. Tell me something that you notice. Okay? Tell me a pattern that you see. 1/2 is different than 3. Okay. What else do you see? What do you see? They're both to the power of x. Okay, that is what an exponential will look like. Very good. It's equal to y. We have y equals, yeah. What else? We're looking for one specific thing. Hint.
The 4 is bigger than
It has something to do with the y-intercept. The y-intercept is what? Look at that. Do you see it?
Yeah.
So this has a y-intercept of 4. This has a y-intercept of 2. What else do we call a y-intercept? Like when we were talking about like fees. The initial fee or the initial charge, yeah. So that first number is the y-intercept, okay? We're going to talk a little bit more about the 3 and the 1/2, okay? So let's keep moving. All right, so we have a general form for an exponential, okay? Y equals a times b to the x. We just dealt with what was one of them, 2 times 1/2 to the x, okay? That's a, that's b. Okay, so a times b to the x is your natural kind of order of things. So a, we just talked about a, okay? It represents the initial value. Okay, we also call that the y-intercept. So that first number a is always going to be your starting value. Okay, b represents the rate. It should say the and then rate, but the rate at which the pattern grows, okay, or decreases. So let's kind of zone in here, okay? We had this one, and then we also had, what was it, 4 times 3 to the x? Was that it? Okay, so I want you to look at both b values. Okay, I want you to look at both b values. The first equation, was it increasing or decreasing? Increasing. That means this one was decreasing, yes? Okay, so there's actually a tie to what's going on here. When b is greater than 1, it represents growth. Okay, or you could put increasing. I'll just put I there. Okay, growth, increase, same thing. Okay, so when b is bigger than 1, example 3, because that was increasing, yeah? Okay, when b is between 0 and 1 or less than 1, okay, when it's less than 1, so 1/2. What's the decimal for 1/2? Yeah, okay, so it's less than 1. That means that it's decreasing. Okay, and we can also call that decay. Okay, decay, if something's decaying, right, it's getting smaller and smaller and smaller, it's going away. So decrease, decay, same thing. Yes. Yes, you're going to have this stuff with some but you're going to get a lot of practice with it. Right, yeah. So basically what it is, it's going to be part of your project, because when you do a mortgage, you have to do exponentials. Everything, like I went and bought my house, was it 2 years ago? Everything was an exponential. It's kind of crazy. So it's not as hard as it seems. I'm going to make it a little bit easier for you. Okay?
Water towards my house last night.
All right. A population of rabbits, okay, is on a large island, and it's doubling every year. Friends, if something doubles, what are you multiplying it by? 2. Okay, can we agree that that's our rate? Yeah. Yes, we can. Okay. It says on January 1, the population is 150. So I want you to think about what we just talked about. Oops. Which letter is the initial amount? Okay. A. A is the initial amount. So our initial amount here is 150. Okay, and we just said our rate was what? Gentlemen, pay attention, please. We just said our rate was 2. Okay, because it's doubling. So we take 150 rabbits, we double them, that's the 2, and then to the x power, it's going to tell us how many years. So I could ask you, after 3 years, what's the population of rabbits? And what would you do? So raise your hand and tell me, what would you do? Raise your hand. What would you do? What would you do? Yeah, you'd plug in 3 facts. So you would do 150 times 2 to the 3rd power. Okay, go ahead and do it in your calculator. You can do it in Desmos too. If you just want to type it in one of the lines, it'll tell you.
I got 1,200.
1,200?
Like from
Anybody else get 1,200? 1,200? Okay, cool. So that's kind of like, this is like probably my favorite unit. It is my favorite unit because it is so applicable, right? Like this is used all the time. And you're going to see even more when we get to mortgages, how it's used, okay? So example 4, a tree is losing half of its leaves every day. There are 40,000 leaves on the tree initially. Write your equation, okay? What's my A value? Yell it out. 40,000. What's my rate? 0.5. Okay, because it's losing half. That's decay. Do we see the difference between growth and decay?
Yep.
Okay. All right, so what if I asked you, how many leaves does it have after 10 days? Okay, go ahead and see if you can figure it out. After 10 days, how many leaves are there? Ooh, something happened here.
Are you kidding me? Ugh. This is so good.
Where's the carrot?
Carrot. Dude. 10,000. 10,000. Wait, we're doing 10 days? Okay. 39 days. Guys, I got you. It's 39.067.
Okay, so that means that there's about 39 leaves left on that tree. Because think about it this way, okay? Day 1, 40,000. Day 2, how many is it going to have? 20,000. It's losing half. Day 3, 10,000.
5,000.
2,500. Okay, so do you see how why it's so small after 10 days? Because it halves each day. Okay? Okay, are we doing okay? We good on that? Yeah. Okay, now that is all for regular exponentials. Okay, now we're going to step into percentage exponentials. Percentage exponentials are much more applicable. Okay, cars, houses, buying gold, like everything can be put into exponentials when it has something, when it has value. Okay, so here's what I want you to look at. Percent increase has a plus. Does that make sense? Yeah, if you're increasing, you're going to add. Percent decrease has a negative. It's subtraction. That makes sense because you're subtracting a percentage off. Okay? Guess what? A still represents your initial value. But instead of B, now we have P. P is the percent. Okay? P is your percent. But we write it as a decimal. So if I told you 20%, it would be 0.20, okay, or 0.2, however you want to write it. What if I told you 7%?
0.07.
Okay, you have to be so careful with these equations. Have to, okay? Because if you put in just 20 for P, it's not going to be right. You have to put it in as a decimal, okay? So, if we have a 21% change, what's going to be my P? 0.21. Okay, we're going to write percent increase with this scenario. So it says write an equation that has a 21% change on an initial value of 100. What's going to go right here? 100. That's our initial value. Okay, what's going to go right here? 0.21. Okay, if I was to simplify that, I would have y equals 100 times, and then 1 plus 0.21 is just 1.21. Yes? You tracking? I just added the percentage, the 0.21 onto 1, because 1 is already in the formula. Okay? And then don't forget your exponential. Yeah, don't forget that exponential. Okay, but what if it was a decrease? Okay, we would still have the initial value of 100, but our percentage is now subtracted. Now we're doing 1 minus 0.21. Okay, so we would have y equals 100 times, what's 1 minus 0.21? 0.79. Okay, we need to make a connection. If you look right here at increase, tell me one thing about the definition of increase from the first page of notes that's obvious right here. Yes, but what has to happen for it to be an increasing graph? Okay, it's right here.
To be
Above 1. Increase is above 1. Look here. Decrease, is that below 1? Yes. Okay. That has to get to that connection. All right, good. We're just going to run through and kind of see if we can figure out what's going on and get a pattern. Okay. Look at A. What's the initial value in part A? -2. Okay. It's always that first number. Keep in mind, we're still using this form. Okay. Some of them just look like percentages. That's okay. Well, can you turn around for me? Thanks. Okay. Is this an increase or decrease?
decrease.
Why? Yeah. Okay. 0.93 is smaller than 1. Here's where my friends get tripped up on this. What is the percent change? Kevin? No. If we start at 1, okay, 1 minus what equals 0.93? 1 minus what equals 0.93? 0.07. What percentage is that? Yes. Do you see the difference? Because we're changing by 7%. Okay, it'll get there. It'll get there. Okay. Initial value for letter B. Okay. Increase or decrease? Percent change. 7%. So you're different from 1. Right? 1 is where you start. You may go positive or you may go negative. But it's the percent change. It's where you're changing from 1. Yes? Do you agree? Are you with me? Do you understand? Okay. So, letter C, what's my initial value?
16.
Increase or decrease? Increase by how much?
33%.
Beautiful. Okay, D, initial value?
1/4.
1/4. Increase or decrease?
Decrease.
Percent change?
21%.
Okay, here's an easier way to think about it. You ready? 1 minus 0.79 equals 0.21. That's your percent change. Okay, so you can do it that way too. Okay, then you can figure out what distance did you go from 1. Down with that.
So the further percent is just subtracting 1 from the decimal that's in.
Yeah. Okay. Yeah. Yeah. All right. You have practice. I'm gonna do this first one with you. Let's do this first one with you. Okay. So, percent increase. Go ahead and write the formula for that. Okay. Same thing with percent decrease. I want you to have the formulas right there. Okay, we're going to go and put those there so that you can see them.
Ferrari.
It's a Ferrari
Is that how you say that? Is that actually a car?
Yeah.
I knew it was Ferrari. I didn't know the name of it. Okay, so suppose your dream car sits in front of your dream home. If it's a brand new Ferrari license, okay, it costs $1,416,362. This car depreciates or decreases in value by 19% every year that you own it.
That's
That sucks, right? Think about how much money you're losing just because you drive the car. Like,
Oh, it's cheap. Easy.
Y'all,
it's cheap.
If I'm buying a water, that is easy.
Okay, write an exponential model to describe this situation. So tell me, what is the initial value?
1,416,362.
Okay, that's the initial value.
I have all that money.
I honestly feel like I'm writing a phone number when I write that.
That's my phone number.
Oh,
Feel like I'm
interesting.
small.
Okay, is this percent increase or percent decrease? Decrease. 1 minus.
0.81.
Okay.
Okay, by what percent is it decreasing?
8.
19%. How do we put that into our formula?
0.9.
0.19. Okay, to the x power. Then part B says use this to figure out the value of this car if you sell it in 5 years. Where are you going to plug in 5? For x, okay? You can put that right in your calculator or you can put it in Desmos.
$493,854.893. Is that and how many years? I thought you wanted me to say that.
No.
It's okay.
Alright, I don't need to be bullied currently.
You just told us.
Okay, that's what you should be getting.
I saw a G.
Does anybody not get what's your name?
I saw a G frame and it cost that much.
Oh, I'm gonna buy that.
With what money?
Okay, I'm gonna let you keep going. Okay, this practice is front and back. Once you get the practice done, if you feel good, then you can go ahead and move on. Okay, but I don't know, like, let me
Which work?
actually, you know what? You really only need to do this today. If you want to start on day 4 and 5 paying for your dream loan, you can, but I'm not going to go over it until tomorrow. Okay, so I would say at least finish the practice today. Okay, if you are not finished with day 2, okay, then after the practice, you need to finish this practice because you have to know how to do this. Okay, but after the practice, you can go back to day 2. Okay, so use your time. I'm going to get out my answer key. Actually, the answer key is online on Canvas if you want to look at it, but I'll also get mine out.
Easy.
Be like the 1954 Buick Roadmaster a little more. You can actually buy. Can I actually buy it?